Hello, this is the last video for this week. It's called The Real Law of Demand, and today I'm gonna draw a bridge between consumer choice and individual demand functions. Just as a reminder, this video is based on Chapter 4 in Bain Prince. And of course, you're always welcome to read Varian if you're interested in this topic. Second reminder, this is a quick recap of what I've covered in the previous video. Talked about the consumer choice problem and the optimal decision rule for the consumer being to select a bundle with the highest utility within the budget set. So that bundle in this picture is represented by point A, and the most important properties of the optimal bundle for the consumer is that all income is spent, so there is no money left because money brings no utility in this story, and that the marginal rate of substitution, that is the slope of the indifference curve at the point A, the optimal bundle, equals the slope of the budget line. So the two lines are tangent in the optimal. So that's the optimal solution to the consumer choice problem, and let's remember it, and we're going to utilize it today multiple times. Here's the plan for today. I'm going to talk about three things. What happens to the optimal bundle when prices or income change? Once we figure that out, we'll be able to derive the individual demand for a particular good from the consumer choice model. And ultimately, we're going to talk about the real law of demand and what the income and substitution effects are. Okay, so the first thing that I want to talk about is what happens to the budget constraint when the income changes. And so here's the toy example that I introduced in the previous video, and I'm going to go back to it because you're already familiar with that. So here's the story. The income is $200, price of X is $25, and price of Y is 10. The budget line is 25X plus 10Y equals to 200. The left-hand side represents the cost of a particular bundle, and the budget line represents all bundles that cost exactly $200. 20 and 8 are the highest amounts of Y and X that can be purchased given income and prices. Let's talk about this. What happens if income falls to $125? We're going to introduce some color coding now. The old budget line is going to be navy color. For the new budget line, we can immediately rewrite the equation by replacing 200 with the new income of 125, and then we can plot it by noticing that, well, the individual can only buy 12.5 units of Y at most and 5 units of X at most given the old prices and the new income. And so these 2 points are connected with a green line that gives us the new budget line. So when income of the individual falls, the budget line moves inward, and you can notice that it's a parallel inward shift of the budget line. You can only buy less of Y and less of X, and it's proportionally less. And the proportion is the same on the vertical and the horizontal axis. Another thing to notice is that when income of an individual falls, that individual is worse off because all the bundles in the red area are not feasible with a lower income. And that should give you a new idea. We're going to introduce a new distinction. We're going to distinguish between the individual's nominal income, that is, amount of money that the consumer has, and we're going to also introduce real income, that is, the consumer's purchasing power. And what the previous example shows is that when nominal income falls, real income falls as well. You have less money, you can buy fewer bundles, so your real income falls. But the interesting part of the story is that real income can change in other situations as well. So your nominal income can change the same, but your real income can be affected when, for example, prices change. So now we're going to look at what happens to the budget constraint when prices change. And so the starting point will be the same old starting point, the same old budget line of $25 for the price of X, $10 for the price of Y, and $200 for the income. Now we're going to keep income the same at $200, but we're going to drop the price of X to $20. First thing, let's write the equation of a new budget line. The new budget line has 20X plus 10Y equal to 200. Income stays the same, price of Y stays the same, but now price of X changes. What does that mean for us graphically? The amount of Y that you can buy isn't changed, because you can still buy up to 20 units of Y. But now the amount of X that you can buy increases from 8 up to 10. And so if we connect 20 on the Y-axis with 10 on the X-axis with the green line, we'll get the new budget line that corresponds to a lower price of X. So you can see when the price of X changes, the budget line turns along the points on the Y-axis. With respect to Y, nothing changes. You were able to buy 20 before, you're still able to buy 20 now. With respect to X, with a lower price, you can buy more. So in terms of the real income, the consumer is better off. He's now able to purchase more of both X and Y, and we can graphically show that with the green zone. These bundles are now feasible with a lower price, so the consumer is better off, his or her real income increases. So our next goal, once we've looked at how budgets respond to changes in income and prices, our next goal is to derive the individual demand from the consumer choice model. So now we're gonna basically recreate the demand function from consumer choices. And recall that in the demand function, we say that quantity demanded of X depends on the price of X, price of Y, income, and the variable H stands for everything else summarized in preferences. So here's what we're going to do. We're going to keep price of Y the same, keep income the same, keep preferences fixed as well, and see what happens to the optimal choice in the consumer choice model when price of X changes. So we'll go back to the original starting point again. Income is at 200, price is at 25, price of X is at 25, price of Y is at 10, and we're going to assume that the optimal point, optimal consumption bundle is 4 units of X, 10 units of Y. Basically, I just need to select some point on the budget line and draw an indifference curve tangent to the budget line at that point. So assume that it's 4 and 10. Then we can say that quantity demanded of X equals 4 on price equals to 25. So the optimal choice for the given set of prices and the given income can be depicted in on a new plane. We can say, well, when price equals 25, quantity equals 4, so that's just the demand point on the price quantity plane. Now let's play with the prices. Let's decrease the price of X to 20. We know what happens to the budget line. The budget line shifts out. In fact, it turns around the point Y equals 20 to accommodate the fact that we can now buy more of X. Now, our optimal bundle has to change as well, because you can see that you can jump to a higher indifference curve given the new budget set. So suppose that the new optimal point is B, where consumption of X is 7. So A was optimal under the old price, B is optimal under the new price. So let's do exactly the same for point B. We're going to mark that when quantity demanded of, we're going to mark that when price of X is 20, quantity demanded of X is 7. And it's going to give us another point on the demand curve. Basically, what is going on is if I look at multiple different prices of X keeping the income and price of y constant, I can always plot the the optimal consumption of x as a function of its price. And if I connect all the dots, I'll get the demand curve. So every point on the demand curve simply represents the optimal choice of the consumer given the price of x and given the fixed income and the fixed price of y and fixed preferences. So the demand is derived from the optimal choices that the consumer is making in the consumer choice model here. Change the price, the budget line will adjust, the optimal point will adjust, and thus the optimal quantity demanded of x will change as well. That is the idea behind the demand curve. And so here is exactly what happens. Demand function is derived by varying px and keeping everything else unchanged. And recall what the law of demand is talking about. The relationship between price of the good and quantity demanded for that good has to be negative, other things being equal. And here, we run into a particular problem. In one of the examples that I've showed you today, when price changes, it affects the well-being of the consumer. The consumer's real income changes as well. For example, when the price drops, consumer is better off because he or she is capable of buying more bundles and consuming more. So strictly speaking, as we change the price in this story, real income is changed, although nominal income isn't changed. So when we want to talk about the law of demand, really we want to think about the relationship between price and quantity when the real income isn't changed rather than the nominal income isn't changed. And because of that, we need to look more carefully into what happens when we change the price. So this gives us the idea of income and substitution effects. So let's go back to the example that I've used to construct the demand curve and look more carefully as to what happens when price of x falls from 25 to 20. The first thing that happens is that the budget line pivots out, shifts out, and the feasible set increases, and so we jump to a different indifference curve at which the utility is higher and consumption of x is higher as well. Consumption of x increases from 4 to 7 in this example. That happens for two reasons. One reason is that x becomes relatively less expensive than y. It used to be that 1x cost 2.5y with a price of 25 and 10. But now, with the price of x falling down to 20, 1x is only worth 2 units of y. So in relative terms, x becomes relatively cheaper. And because x is relatively cheaper, you would want to substitute y away from x. Sorry, I didn't say it right. Because x is relatively cheaper, you want to buy less of y and more of x. You substitute toward x. And the second story is with a lower price of x, the consumer is better off, his or her real income increases, and in principle, you can increase your consumption of x because your income increases, even if the prices originally remained unchanged. So we want to separate these two reasons, separate the two effects, the substitution effect of a relatively cheaper price of x from the income effect of a higher real income. And the question is how to do that. There is no obvious way to do that. So here's the idea. Bundle A is the bundle that corresponds to the old real income and old prices, and bundle B is the optimal bundle under the new real income and new prices. And the new real income is tied to the fact that the price of x has changed. So somehow we need to separate these two conditions, and we need to come up with an intermediate bundle which will have one thing in similar with the original bundle A, and one thing is similar with the new bundle B. So here's how we're going to proceed. We're going to construct bundle C that will correspond to the old real income, but on the other hand, it will have the new prices. How do we get it? Well, because bundle C has to be optimal under the new prices, it has to be optimal under some budget constraint that will have the same price ratio as the new green budget constraint. On the other hand, if it has old real income, it has to be somehow similar to A. And the usual understanding of the same real income is that the highest utility you can get is the same as the highest utility that you can get under bundle A. So to sum things up, bundle C and bundle A have to be on the same indifference curve, and bundle C has to be optimal under the same price ratio as bundle B. In effect, if you think about it, as you move from A to B, change the price, so you would want to buy more of X, and you increase the income, so you would probably want to buy more of X as well. And so to construct C, we basically want to start off with point B, and we want to reduce the nominal income, because a reduction in nominal income will mean a reduction in real income. And if we do that carefully, we can arrive at bundle C. So now I'm going to press the button and show you what bundle C is, and then I'm going to go over the reasoning one more time. Here is the bundle C on the graph. Between B and C, you can see that bundle C is optimal with respect to some new green budget line. What am I trying to achieve here? C is optimal with respect to some green budget line, and at the same time it lies at the same indifference curve as A. Because A and C lie at the same indifference curve, we call it the same real income. In terms of utility, the individual, the consumer, gets the same utility at A and C. So in terms of real income, you should think of those as being the same. The green line corresponds to the new price ratio. So the difference between C and B is only in the level of amount of money. Basically, to find C, we start with B and take away the money from the consumer up to the point when their optimal consumption bundle happens to be on the old indifference curve. So we extract some nominal income away from the consumer to bring them to the old real income to see how much they would choose if they got the same utility, but the prices were different. And so between B and C, price ratio is the same, so you can think of that as the same set of prices. But the nominal incomes are different, so the real incomes are different as well. And so then, if we assume that at C, consumption of X is 6, we can say that the substitution effect, the effect of price change keeping real income the same, is going to be equal to 2. That is, because X is relatively cheaper than Y, you increase consumption of X from 4 to 6. That's going to be 2. The income effect, that is saying that price of X causing your real income to increase, actually corresponds to just an increase in consumption of X from 6 to 7, and that's just 1. So what we have achieved here is we've looked at the total change in consumption due to a decrease in price of X, and that total change is 3. And we said that actually the consumption increased for 2 reasons. Because X became relatively cheaper than Y, so we jumped from A to C. And because the consumer got wealthier, his or her real income increased, so we jumped from C to B. So we split the total change in consumption into 2 parts. And this gives us the idea of what the real law of demand should look like. The substitution effect is always negative. And that's not a trivial observation, because here actually I'm saying that substitution effect is 2. But remember that the price has dropped. So basically, when we're talking about changes in quantity demanded, we want to keep the real income the same. And so we want the change in quantity demanded to go in the opposite direction from the change in price. So if the price of X increases, substitution effect being negative means that quantity demanded of X has to go down, no, for the same real income. If the price of X goes down, quantity has to go up. That means that the substitution effect is negative. The income effect in general does not have to follow suit of substitution effect. Depending on whether good X is inferior or normal, income effect can be positive or negative. There is no restriction on that. But there is a restriction on substitution. If X becomes relatively cheaper than Y, you should demand more of X and less of Y. That is the idea here. Okay, thank you.